So from today we are going to start a new unit. The first unit, electrostatics, has been completed till last class. The next unit, unit number 2, is known as current electricity. So as the name suggests, and this is the starting of the new unit, unit 2, which is termed as current electricity. Current electricity. So this particular unit is somewhat similar to what you have learned in class 10. In class 10 you might have learned about electric current, electric charge, the movement of the electrons in the conductor, Ohm's law, etc. So all those things will be studied again here in this particular unit also. So the first topic in this particular unit is electric current. Electric current. See, before we define the term electric current, see, we should know the concept of movement of electrons inside a conductor. When you have a conductor, let us say the conductor is in the shape of a cylinder, then inside the conductor, the charged particle, that is electron, let us say one charged particle Q, moves across the conductor from one end to the other end. Either it may be electron or proton, etc. Generally, the movement of the electron gives rise to the conduction of current in a material. So let us say the charge Q, while moving from this first end to the second end, from on the first edge to the second edge, it takes a time t to move across the conductor. So you have a conductor across which the charge Q is moving from left to right, and it takes a time t. Then this electric current is defined as the charge flowing through the conductor per unit time. So electric current is a quantity which gives the amount of electric charge passing through the conductor per unit time. This is known as electric current. And this particular electric current, will be symbolized by this I. So I generally represents electric current, and it is defined as electric charge per unit time. Then if a small charge dq, while small charge, infinitesimally small charge dq, while passing through the conductor, takes a small duration of time dt. Apikpa charge dq haiba ma conductor manung sida satpa kanda time dt khatang changba taragadi, then we define instantaneous current as differentiation of q with respect to t. So dq by dt, this represents instantaneous current. So instantaneous current si ko represent tabu kanda differentiation of q with respect to time t and alone. So this is how we define instantaneous current. Then for every physical quantity khuding maki ayam matamda magi kaino laigani unit laigani ko, the SI unit say kari oigani have kanda. So the SI unit of electric current is ampere. Ampere ne spelling one is have target a masana over is ampere, capital A. When you write the SI unit, when you write it in the long form, it should be starting with a small letter. It is from the sign convention in physics. ampere hai iba kan nang unit oin sin na bakan di e masana ho gadau ni aduga when you write the notation it should be capital E yare ko aduna let us take 1 coulomb of charge 1 coulomb of charge am lower say and while moving through the conductor sige conductor sida sakpa kanda conductor manung sida sakpa kanda if the time taken is 1 second ko karigumba 1 coulomb ki charge amana conductor sida power sakpa matamda 1 second sang ba taragadi then current du madu ki current du ko koina 1 ampere kawi haidu say I equal to q by t ni sida lai se masida nang na current si 1 ampere tahange haiba taragadi charge so 1 coulomb lo tare time do 1 second lo tare so 1 coulomb can be defined like this 1 coulomb is the electric current passing through the conductor when 1 ampere is the electric current passing through a conductor when 1 coulomb of charge takes 1 second to move across the conductor haigo amka na haige 1 ampere haibasi current ni karamba current madudi 1 coulomb ki charge amana conductor du ki across ta satpa kanda matam 1 second lo taragadi haiba conductor du fall iba current do ikona 1 ampere ko gani ha ko so some of the smaller units of current di kaino haimo kanda MA haini iramba taragadi milliampere haibani milliampere means 10 power minus 3 ampere ko aduga 1 microampere haini iramba taragadi 10 power minus 6 ampere ni notation se ana MA haigadi milliampere 10 power minus 3 ampere aduga microampere haigadi 10 power minus 6 ampere nano ampere haigana NA hana igani asina kaidorani 10 power minus 9 likewise pico fermi and mayama mathang lai ko these are the smaller units of electric current this is all about the introduction of electric current then let us see how the electrons in a material behave when electric field is applied suppose electric field amada field apply to have the battery connect to the conductor ama I smile lower see suppose this is a conductor why do we call this material as a conductor because it contains free electrons mayamam yawani free electrons mayamam mas minor is electrons minor loina lagini pa these electrons see I goina magi terminal sida plus minus sida battery ama same key se open tawre key se open tawruga thamba kanda sigi keno sida conductor sida current amata sen diro although the battery is there the key has been disconnected under this condition when no current when no electric field or no potential difference is applied the electrons in the material in the conductor are randomly directed moina pamba lambi amada sumain direct tawun ko these electrons are randomly directed ana electrons in se mana satpa pamba direction da satkani aduna before electric field is applied before potential is applied the average velocity set see first electron ki velocity u1 hai ro second electron ki velocity u2 hai ro adu main tawdana nth electron ki mai velocity do un hai ro si mayam sigi velocity mayam gi min lawraga number of electrons divide tawse masi average velocity se masi 0 ta kani ha aduna why it should be 0 because among the electrons there might be some which are oppositely directed sumaina electron ani si velocity mayam sing si cancel chalam yai maram aduna asigi velocity mayam plus minus tauna kanda the average velocity becomes so much small that we can neglect it. So before electric field is applied to a conductor, the electrons which are moving inside the conductor, they are randomly directed. That's why that's why it cannot conduct. It cannot conduct electricity. So the average velocity is 0. But however, when the key is closed, like this, let us think what might happen to the electrons. Electrons, as you know, they are negatively charged particles. So these electrons will be repelled from the negative end. Sigi can say electrons initially before electric field applied to the average velocity to 0 tare. However, aikoina kaino tawraba matungdadi electric field applied tawre key close tawre current flow tawrani aduga sida electrons ngasai sigi negative terminal lom sidagi repel tawraga as light charges repel tawunina electrons so opposite terminal sida smaina la ani ha. So the electrons will start moving from the negative terminal to positive terminal, and they will be properly directed in a fixed path. I don't know, electrons in say right side to left side to the punna minor move toward. That means from negative terminal to positive terminal. Then such uniform movement of the electrons gives rise to the flow of electric current in the opposite direction. So the current will start flowing in opposite direction to that of movement of the electrons. And this is what you mean by conventional direction of electric current. Conventional direction of electric current. So this particular explanation is all about conventional direction of electric current. So according to the conventional direction of electric current, the direction of flow of electric current through a conductor is opposite to the flow of electrons. This is what you mean by conventional direction of electric current. And another concept is that when you take the velocities here, the velocity of the first electron, velocity of the second electron, velocity of the third electron, velocity of the fourth electron, this value may or may not be the same, and when you take the average, say let us add all the values, all the velocities after the electric field is applied and divided by n, and this will not be 0 because there is no opposite velocities here. Electrons in opposite direction, they are moving in a fixed direction. Then this particular average velocity will be termed as drift velocity. In your next classes you will learn about this drift velocity. Right. So in today's class, what you have learned is electric current, SI unit, and how the electrons behave inside a conductor when you apply electric field. And from that concept, it gives rise to conventional direction of electric current. Okay.